Hey everyone, and welcome. I am so glad you're here today because we are about to go on a really cool mathematical adventure. No, seriously, it's going to be fun. We're going to crack the code that describes everything from your favorite coffee shop's location to how your social media apps work. And it all kicks off with one big question.
It sounds a bit like a riddle, right? I mean, how on earth can you pinpoint any spot, anywhere, in a space with just two little numbers? Well, that's exactly what we're going to figure out. And trust me, the answer is way simpler than you might think.
And here it is. Meet the hero of our story. Yeah, it might just look like two lines crossing each other, but this grid, the Cartesian plane, is honestly one of the most powerful ideas in all of mathematics. It's the ultimate map that lets us turn real-world spots and shapes into numbers we can actually work with.
So let's get the lay of the land, shall we? That line going side to side, the horizontal one, that's our x-axis. Just think of it as left and right. And the one going straight up and down, the vertical one, that's the y-axis. Think up and down. That spot right in the middle where they cross paths, that's our home base, our starting point, called the origin.
Okay, so how do we actually use this map? With something called coordinates. A coordinate pair looks like this, x, y. You should think of it as a secret address for any point you can possibly imagine. The first number, x, tells you how many steps to take left or right. The second number, y, tells you how many steps to take up or down. That's all there is to it. And this is a perfect example. See that point B over there? Its address is 2, B. All that means is we start in the middle, we go 2 units to the right, and then B units up. And what's so cool is that every single point on this entire plane has its very own unique address. Just like a house on a street, no two points can be in the exact same spot. All right, so we've got the map and we know how to find all the addresses. Now for the really fun part. Let's add a couple of awesome new tools to our math toolkit. We're about to learn how to measure the distance between any 2 points and how to find the exact halfway mark. First up, distance. And it's pretty much exactly what you think it is. If you could take a ruler and measure the perfectly straight line connecting 2 points on our map, well, that length is the distance. It's the absolute shortest path you can take to get from point A to point B. And here's the magic recipe for figuring that out. Now, I know, it looks a little intense at first, but I promise it's not. It's really just a clever math trick. You just find the gap between the x values and square it. Then you find the gap between the y values and square that. Add those two results together, and then find the square root of the whole thing. And boom, you've got your distance.
Okay, our second tool is for finding the midpoint. This one's super easy to picture. Imagine stretching a piece of string between 2 of our points. The midpoint? It's just that exact spot where you'd fold the string perfectly in half to find the dead center.
And get this, finding it is so easy. It's literally just about finding the average. All you do is add the two x coordinates together and divide by 2. Then you do the exact same thing for the y coordinates. And just like that, you have the address of the perfect halfway point. How cool is that? Okay, so we've totally nailed points, distances, and midpoints. But now we're going to zoom out a bit and look at something even bigger. We're moving beyond just single spots on a map to the connections between them. We're talking about relationships. I just love this quote because it is so true. You know, a lot of us think of math as just a bunch of lonely, isolated numbers. But it's not. It's all about how they connect and talk to each other. And when you start to see those connections, you start to understand the world in a whole new way. So what exactly is a relation in the world of math? Well, it's really just a rule. It's a rule that describes how things in one group are linked up with things in another group. It's the why or the how behind any connection you see. And it turns out there are really just a few main ways that things can be connected. So let's go on a quick and fun visual tour of the 4 big types of relationships you're going to run into. First up, the one-to-one relationship. This one is super straightforward. As you can see here, everything on the left has one and only one perfect partner on the right. Distance goes with kilometers. Volume goes with milliliters. It's a perfect matchup, nice and tidy. Okay, next up is many to one. So take a look. We've got a rabbit, a cow, a horse, all totally different animals, right? But they all have one thing in common. They're all herbivores. So you have many different items on the left, all connecting or kind of funneling down to one single category on the right. Now, let's just flip that whole idea on its head. This is a one-to-many relationship. Here, we have one person, Rania, and she's connected to several favorite subjects: science, math, and language.
See how that works? One single starting point can branch out into a whole bunch of different connections.
And for our final stop, we have the many-to-many relationship. Now this one can look a little messy, but it's probably the one you see most often in the real world. You've got multiple students connected to multiple ways of getting to school. Feiruz and Ravi both might take a car, but hey, Ravi also sometimes takes the bus, and so does Afik. It becomes this big, interconnected web.
So what's the big deal with all this? Why does any of it matter? Well, because once you start to see the world in terms of points and distances and relationships, you start to realize your whole world is built on this stuff. You begin to see the hidden math, the secret structure, underneath literally everything.
And I'm not kidding, it is everywhere. That GPS in your car, it's crunching coordinates and distances nonstop. Your favorite video game, the whole level is just a giant coordinate plane. That app that delivered your lunch, it's mapping a path. The way social media suggests new friends for you, that's a huge many-to-many relationship in action. Even when we look up at the night sky, we're using this to map out the stars. It's like the invisible blueprint of our modern world.
So I'm gonna leave you with this thought. You now have the key. You've cracked the code. You get the map, you have the tools, and you understand the connections. So my challenge to you is this. As you go through the rest of your day, try to spot them. What other hidden mathematical relationships and coordinates are running in the background, shaping your world right now? Thanks so much for hanging out with me.